Hello, this video is a lecture for 7.2 section handout. In this section 7.2, we basically find two things. One is area. Also, we can call area as a probability, and other things we will find in this section is x value or z square. Okay, and notice that for area or probability, we use function normal CDF. Okay, but to find the x value or z square, we use a function in norm. Again, I'm going to show you how to do it using calculator with the problem, but make sure that to find the area you use in normal CDF function in the calculator. To find the x value or z square, we use in norm. Okay, let's talk about the basic. I use the acronym LB for lower bound, UB for upper bound. Okay, and look at this symmetrical bell-shaped curve. This point here is the mean, obviously, and this line here either x or z, and you can see from the graph that tells you either x line or z line, or this is x value. X value is data value, either going to be here or z square going to be here. Okay, and let's say you have a points A here on this line, and think about the area on the left of A under this curve. You see that shaded area? That is called left area. Okay, left area. And here for this left area, if you look at the bound, we call BOUND bound. This point here is called upper bound. Any value less than A here is lower than A, right? And how far you go to the left, you don't know, because what happens is this curve and this line never met. Therefore, in this particular situation, there is no lower bound. We say lower bound is don't know. We don't know that. Therefore, by the time we use negative 10 to the power 99 as a lower bound. If you don't know the lower bound, you use negative 10 to the power 99 in the calculator. And if you look at this inequality, x less than equals to a, because of less than, this whole thing represents area on the left, and also it's called probability. Whatever this shaded region here, that is area, and also this is the probability, this probability. And notice that it could have x or could be z. This could be probability x less than equals to a, or probability x z less than equals to a, could be. If you have a question to find phi x less than equals to a, think about the left area and determine what's the upper bound and lower bound. That's very important. Similarly, for this second graph, you see that the red shadow here represent right area, because this area is right at the point B. This B could be x value or could be z value. Therefore, if you look at this probability, this tells you this area is a probability of x greater than equals to, I should say B here, because we use B points here, greater than equals to B, or probability of z greater than equals to B. That's called right area. Then if you have a right area, you should have lower bound as a B. You know lower bound, this number is a lower bound. But upper bound, we don't know. By the time we use 10 to the power 99, positive, in the calculator. Remember that we are using upper bound, lower bound in the function normal CDF to find the area or probability. For part third part, and look at here, this is bounded area, because this shaded area here between A and B. Therefore, this area has lower bound A, upper bound B. And by the time to find the area, you use upper bound as a b to the right value, lower bound to the a as a left value. And this is called area in between two points A and B. Remember, this line could be x, could be g. Therefore, the probability between A and B, okay, that variable could be x, could be g, and that is area or probability which represented by this middle shaded area. Okay, that's the little things you get to know to find the area in the section 7.2. Let's do the first question here. Of course, you have a blank handout. I already have an answer for each one of those. I'm just going to explain this for you. Okay, look at the first question. Find the area to the left of x, okay, or find probability of x less than or equals to 35. Either, listen, sometimes it just tells you find the area to the left of x, okay, and sometimes if it doesn't have this one here, let's say this is another question. This is same as saying find the area to the left of x is same as saying find p x less than or equals to 35. Because if you remember the previous discussion here, watch here, see this area here, which is left area, is same as what? X less than equals to a, right? Therefore, here in this particular question number 1, if you compare, a is 35. A is 35. Therefore, either you're looking for this area or looking for this probability. That's the same thing. Therefore, again, I told you before, to find the area or probability, use normal CDF. And what do you need? Upper bound, lower bound. If you look at the notes, I think you have a notes you took first 5 minutes from this discussion, right? Remember I told you what's going to be upper bound, lower bound for different types of the graph, correct? Therefore, in this case, since you have this area as a left area, this point here is 35, left of 35. Okay, this point is 35, and this area is left area. Okay, then 35 is going to be upper bound. LB for lower bound is negative 10 to the power 99. That's how I told you. The mean, this is x line. Look at the x value here. This point in the middle is mean. 38.72 is the mean. But I need a standard deviation as well to find area, because in normal CDF you need 4 numbers: upper bound, lower bound, mean, standard deviation. What's the standard deviation between these two numbers? What's the difference between 41.89 and 38.72? You subtract, you get 3.17 standard deviation. Now you go to the calculator, okay, find normal CDF. With normal CDF, this is same place where you find the binomial CDF or binomial PDF in binomial distribution. You're going to do second and VRS. Let me just again, you do second here, VRS, and you do number 2. See, you click number 2. That's called normal CDF. It depends on the calculator. Some of you might have a row to input it. You might say upper bound, lower bound, mean, standard deviation option. But here you have this card has this kind of option. You got to type is first number you type is lower bound. You type negative 10 to the power 99, comma, upper bound is 35. That's what you said before, 35, comma, mean is 38.72, 38.72, comma, standard deviation is 3.17, and remember that, close this open parenthesis in normal CDF and close it. Now enter, you get 0.12029 because of 4 decimal, this 2 becomes 3. Okay, and that's how we have this number here, and that's the area. And this area here, 0.1203, is this area. In other words, it is about 12%. Remember that whole area, if you consider 100%, this little area here, this area, which is shaded area, is about 12% of whole area. Okay, it makes sense too. Therefore, this area is 12%. In other words, the probability that x less than or equals to 35 is 0.1203. And also I put here p x less than or equals to 35 equals to 0.1203. Okay, that's the answer. That's the question number 1. We find the left area. Look at the question number 2. Question number 2, find the area to the right of G. And here we're looking for the right area. But notice what's different between these two graphs is this graph has an x as a line, but this graph has a z as a line. If you have a z line, this mean is always 0. In other words, the mean z-score is always 0. That's always must be. Notice that if you have a z line, this mean always 0. Therefore you see 0 here. Okay, and find the area to the right of z is same as saying find the probability of z greater than or equals to 0.76. This value is 0.76. Notice that this point is 0.76. This the z equals to 0.76. Looking for the area to the right. Look at the right of the 0.76. Okay, and thinking about the right area, let's go back to the second graph. Remember that what do we say about the right area? For the right area, this point here, whatever x or z, this point is going to be lower bound, right? And upper bound, we don't know. Then we use 10 to the power 99. Make sense? That's what you need to be careful about, upper bound and lower bound. And in this case, I put it there. Upper bound is 10 to the power 99 because you don't know upper bound. How big is it? How big z value going to go to the right? But lower bound for this area is 0.76. Is 0.76. The mean is 0 obviously, but the standard deviation is 1 because remember that from here to here you subtract 1 and 0. That's why you get 1. Like first question, how do you get a standard deviation? You subtract this minus this, right? First here, right? So in this graph, standard deviation is 1. As long as you have a z, that's the 1 standard deviation. And use normal CDF again like before and put in the calculator. Let me show you that again, same as before. And you start with second VRS number 2 as a normal CDF, and you put lower bound, which is 0.76. 0.76 must be put in order, comma, upper bound 10 to the power 99 because we don't know upper bound, right? Comma, the mean 0, comma, standard deviation 1. Close. Therefore, this whole thing, when you enter, you get 0.2236. 0.2236. That's the area. Whatever we're looking for, this area is 0.2236. For area on the left, on this curve, from this point, 0.76 is 0.2236. In other words, this area is about 22% of whole area. Think about 0.2236 as a proportion. As a percentage, it's going to be 22.36, right? I should say 22%. This area is about 22%. So we call probability P z greater than or equals to 0.76 equals to 0.2236 because we say probability as an area here. Okay, I'll mention that here. This, whatever you get the number, this is also probability. Make sense? This is for second graph, we had it before here. Now, um, if you have a area between 2 points here, obviously here you're looking for area between 0.68 and 0.82. Now you have this first point on the left is lower bound, and second point on the right is upper bound on this area. Therefore, this area here in between two numbers, therefore this is lower bound, this is upper bound. What's the mean? 0, because this is the z line, and standard deviation is 1. Again, I told you before. And you put in the calculator like before. I'm not going to put that because this is exactly the same as I did in the last two questions. Normal CDF, lower bound, comma 1.82, comma 0, comma 1. Again 0, comma 1. Mean standard deviation has to be in order, equals to 0.7173. And that's the same as the probability of z score between these two numbers is going to be 0.7173. You see that? That's the answer. Make sense? Okay. This is the question number 3. Let's do question number 6, because this question is also about area. But notice that when you read the questions, you have to be careful. If you have a question to find the area or whatever x or g value, always draw the graph first. This makes your life easier. Therefore, I always mention in the handout, draw the graph first. Draw it, the graph. Then you can see which area you're looking for, right or left. Okay, even it tells you left of whatever and right of whatever here in this question. But if you draw the graph, it's going to be easier. Listen, how I draw the graph? I draw the normal graph here, also called bell-shaped graph. I put 0 in the middle. You know why? Because this is the z score is here. Z is given. Therefore, I put 0 here. And I mark 0.24 negative here on the left of 0 somewhere here. Doesn't matter. You just kind of be nice and not make a scale 1, negative 1, negative 2, 1, 2 like that, and mark negative 0.24 somewhere here, and mark the left area. Okay, highlight the left area. Similarly, mark 1.20 on the line, that z score 1.20, see, and mark the right area. And pretty much you have a left area that I name as first area I name this second area as II. Okay, area I going to be left of negative 0.24, that's called left area. Area I is left area. Area II is the right area, right of 1.20. And you know how to find the left area and right area from the question number 1 and 2. You do exactly the same thing. All right. And what you need upper bound, lower bound, and mean and standard deviation. Obviously, because of z line here, mean is 0, standard deviation is 1. Okay. And for the first area, I area, this area, you use normal CDF, lower bound negative 10.99, upper bound negative 0.24, comma, mean, comma, standard deviation, and then you get 0.4052. For this area, the I area equals to 0.4052. That's the left area. For this second area to the right area, you use 1.20 is lower bound, okay? And upper bound, we don't know. You use 10.99. Therefore, I use 10.99 as upper bound. But to find the area II, second area, use normal CDF 1.20, lower bound 0.99, upper bound 0,1 in the calculator. And you find two area, correct? And you add them total. You'll find this total area. There is another way to do it. What's another way? You find this middle white area, correct, and subtract from 1 to get the remaining area. Therefore, rather than doing this one, you can just do is this. You can just find the middle area. Well, how do you find the middle area? You know how to find the middle area? Again, let me clear that here. Second VRS. Number 2. To find the middle, lower bound for the middle means white area, minus negative 0.24 lower bound, comma, upper bound is 1.20, comma, mean is 0, comma, standard deviation is 1. Okay, and you get this, and you get 0.47 9765, and you subtract 1 minus, because you know the total area under the curve is 1, and if you subtract the middle white area, you get this shaded area, 2 total, right? 0.47965. Let's do this. They get 0.5203, 0.520. It's a little bit off here, but what happens is this error of like 10,000 places, you're going to be fine, right? Therefore, this 10th, 100,000, 10,000 places error, 0.0001 error, that's okay. Alright, that's the question number 6. Alright, so far you are learning is how to find the area, right? Or how to find the probability. Does that make sense? Okay, let's do question number 9. Okay, 9 is also about finding the area, but it asks you what is the proportion. Okay, what's the proportion of the employee who earn less than or equals to $45,000? Therefore, if you see the question, what's the proportion, you're looking for area, because remember that we mentioned before, area is same as proportion. Also express area as a proportion or probability. Therefore, in this section, in this question, what is the proportion, right? Okay, I say proportion as area here as well. Now you're looking for basically is the right area or left area. That's what you're trying to figure out. And if you read the question carefully, it says what is the proportion of employee who earn less than or equal to. If you say less than or equal to, obviously this is going to be left area. Therefore, to find the left area, what do you need to have? Lower bound, upper bound, mean, and standard deviation. And every information is going to be in this question. You can find easily. But let me draw the graph first. Since I say draw the graph first, I want you guys to draw the graph first. That's the graph looks like. Okay, what's the annual salary of the employee in the large electronic company? And remember, they say approximately normally distributed. Therefore, I can make the normal graph. This is the bell-shaped graph, which is called normal graph. And watch here. This is the normal graph. This is the mean. Okay, in the middle, 50,000. That's the mean of 50,000, right? And the standard deviation of 2,000. Okay, I didn't put 52,000 here, 48,000 here. I didn't put it here, but I could put this number as 52,000. 52,000. I put this number as 48,000, but I don't have to do that necessarily. But I need to mark 45,000 number here because I'm looking for the employee proportion who on less than 45,000. Therefore, what I did here is I put 45,000 and I mark the area on the left of 45,000 because it's a less than, okay, less than or equal to. Remember that in this normal distribution, even if it's a less than or equals to, the answer does not matter. It's the same thing. In other words, p x less than a or p x less than or equals to a is the same. Therefore, use the same thing, normal CDF function. Therefore, looking for area on the left of $45,000. Remember that this line is X line here, not Z, because the mean here 50,000 is X data points as a mean. If the Z, this mean gonna be 0. Notice that. This is the X value, therefore I put X here. Here X represents the salary. That's the average salary, 50,000, and 45,000 is the one of the X value. And the question is asking for how much proportion of the people who earn less than 45,000. Okay, therefore we're looking for P X less than equals to 45,000. And what I did, I used normal CDF, and again this is the way how to find the left area. And we found left area a couple of times before. In the left area, lower bound is negative 10.99. This points must be upper bound, 45,000 upper bound. This is the mean, 50,000. Standard deviation 2,000. And put in the calculator, you get 0.0062. And that is a proportion. That is a proportion. P-R-O-P-O-R-T-I-O-N. Also probability. P-R-O-B-A-B-I-L-I-T-Y. Alright, also we call area. Area of what? Under the curve left to the $45,000. In other words, if you change as a percentage, this is going to be 0.62%, right? In other words, 0.62% employee has salary less than or equal to 45,000, okay? But that means almost 1% or let's say 1%. If you round it up to the whole number, you can get 1%, right? 1% people has a salary less than equals to 45,000. That's what it called. Okay, that's all about how do you find the area using normal CDF. I finished those questions on the handout. Okay, my point is, did you guys understand how do you find area using normal CDF? You get it? Either right area or left area or middle area. Okay, you use normal CDF to find the area or probability. Okay.